Okay, so this is question 1. The diagram below shows part of the graph, f of x equals a cosine of b times x minus c, and then minus 1, where the lead coefficient a is greater than 0. So that's actually something that's noteworthy here. This value a is positive, okay? It says so in the question. All right, just keep that in mind. That makes it a lot simpler. We don't have to worry about any reflections across the x-axis or anything like that. So here's what we got. The point P is at the top of the graph. It's pi over 4 and 2. They show you this, and of course the other point Q is at the bottom, and the minimum point, so they show you this. Find the value of A. So if you really understand what these components are in the graph, A, B, and C, and what have you, this is actually pretty trivial. This value A is the absolute value of that, really, is the amplitude of the graph, because it's a wave, and waves have an amplitude. So the amplitude is measured from the middle of the graph to the top. So here's the middle of the graph, the midline, the center of the wave, in a sense. And that distance from there to the top is your value for the absolute value of A. A is already positive, though, and we just have to figure out what this is. So how do we figure out what that distance is, okay? Well, that's pretty easy if you use information available to you. I know that this top point here, this y value, they tell me right here, this is the y value 2. And here, at the very bottom of the wave, this is the y value negative 4. So basically I'm asking you, what is the distance from here to here? The distance between 2 and negative 4 is going to be 6. So there's a symmetry of this. If this is the middle of the graph, right, we're looking at 3 and 3. If that whole thing is 6, right? So it stands to reason that this amplitude here is just 3. It's half of that. Okay, so that's your value for A. Really, really simple question. Not a whole lot of work you can show for that either. Okay, now they're actually asking me to show work for part B. Show that the period of the graph is pi. Now, you have to have an intuitive understanding of what a period is on a sine wave, or a cosine wave in this case. It doesn't make any difference. Okay, it's the same thing, same concept, right? So here's the deal. If I were to continue this drawing for this wave, even though it's pretty horrible, let's try this. It would do something like this. And keep going. The deal is, here's how this works. I can measure the period of the graph from the top to the top or the bottom of the graph. This is true. I can measure from here to here or from here to here, and that's the length of the period or the cycle. So if I know that, okay, and they're telling me that distance here is pi, they want me to prove that distance here from here to here is pi. Okay, well, that's pretty straightforward. But I don't really know what this particular value is for x right here. So it's hard to use that point. But I do know this. I do know this x value on the bottom. And I know this x value right here on the top. And here's the deal. If I'm measuring this period from one top to the other, what's the halfway point from the top of the graph to the top of the graph? The halfway point is right here. And that will be where the bottom is. So basically, if I just measure from here to here, and let's do that in a different highlighted color, like red, just measure from here to here, that's half of the period. Okay? And I can figure out that distance because I know those two green x values right here that I've highlighted. Okay? So that distance is really this x value minus this x value right here. Okay? So what is the difference between those? That's going to be half of the period, mind you, right? Keep that in mind. It's half of the period. So here's the formula I'll use. I'll say that my period, I'll say let P equal period, right? And I'll say this. 1/2 P, 1/2 the period, is equal to this x value here minus this x value there. So it's going to be 3 pi over 4 minus pi over 4, which is 2 pi over 4, which is pi over 2. Okay, if you reduce that fraction. So if I tell you 1/2 p is equal to pi over 2, and then I multiply both sides by 2, then the period will equal what? It'll equal pi. And this effort right here is the work. So you must show work. They already tell you the answer. You can't just say that the period is equal to pi. Yeah, of course it is. They told you that. They told you that right here. So if that's not worth any points, just writing this. Okay? They're looking for the work. They want you to show the work. So make sure the questions like that, you are showing work instead of just writing the answer that they already give you, which is worth nothing. Okay? You're probably thinking, why do I have to say that? Why do I have to tell you that? But you'd be surprised. Some people just literally just write the answer that they already gave you. So you really didn't do anything. Okay, so just keep that in mind. Hence, find the value of b. Hence means use the answer we just got from the previous question. Find the value of b. All right, then. So if I do this, if I'm finding the value of b in this equation is right here. Okay? And what I taught you is it's used to analyze the period of the graph. Now there's a disconnect here from the way this equation is written and the equation I taught you when I taught you how to graph sine waves, cosine waves. I taught you this equation. And how to find things. Okay? The difference between the equation I taught you and the one they're showing you is they factored out this quantity called b. They factored it out of this parentheses here. That's not going to change the value of b at all. That b is still the same if you factor it out, but it will change your value for c. Okay, this is kind of a different thing. My value for c in the equation I taught you is not going to be the same thing as this one because b has been factored out of it. So that's going to change it a little bit. That's the part that will get confusing for some people when you're thinking about what I taught you versus what is being shown to you. Okay, but it's really not complicated. It's just one little thing about it, and that's what I'll talk about here. But the b is going to be exactly the same. It's not going to change. So if I factor it out, it's still the same value right here. These are exactly the same value. So how do you use that? Well, b, the period I taught you is 2 pi over b. And they're telling you the period, you found it or proved in the previous question, that's equal to pi. So all you really got to do is solve this equation to find the value of b. Solve the equation for b. It's really, really goofy. So we have this right here. Here's the equation that you have right here. And we're just going to solve it for b. So rearrange it. B is going to equal 2 pi over pi, which is just going to be 2. That's kind of a goofy question. Okay? And it says, last question, given that c is between 0 and pi, write down the value of c. So this is your phase shift, okay? The way it's written directly here, if they are to give you this equation that's factored b out already, which they have, then c itself is just directly your phase shift. This is the phase shift. Directly. You don't have to do any modification. It's just the value c. So what's the phase shift anyway? It's a horizontal shift. What I taught you in class is that you should expect or anticipate where this graph should start ordinarily before it's been shifted. It's a cosine wave. So cosine should start its graph on the y-axis at the top. Remember this top line right here? It should start at the top line. But it's not starting there. It's starting somewhere over here on the bottom. So what's happened is this top part is shifted. This point, which should be the top of the wave right here on the y-axis, has been moved to here. It's shifted. So this coordinate right here, it would be 0, 2. That's where it should be. And it's moved to this coordinate, which is pi over 4 and 2. So I shifted to the right by how much? By pi over 4. That point right here is moved from here to here by pi over 4 to the right. And it's moved to the right because this is a minus sign. So that's your value for C directly. It's directly from the graph. It's just pi over 4. This value C right here is just that shift. It's pi over 4. So that's an easy question, technically. Now, what makes it complicated is because of the way I taught you this. If you are using this formula the way I taught you, right, religiously, if you don't make that translation, I told you that the phase shift for this formula that I taught you is C over B. If you don't factor out the B, it's going to be this quantity C over B, like this. So I told you the values C for the equation I taught you and the one they have are not the same, okay? So in this case, if I'm finding C for my original equation, right, I would basically say, okay, my phase, this is equal to my phase shift to C over B, and I know that's going to be pi over what? Over 4. I can see that from the graph. And I know that B already is what? I found it in the previous question to be 2. So think about that. If this is what I'm playing with here, this is going to be C over 2 is equal to pi over 4. If I multiply both sides by 2, that's going to be 2 pi over 4, so C is going to be pi over 2. This is not a phase shift. The phase shift would be C over B, which is the answer, right? But this is not the same thing. So basically, that's where the confusion might arise with these formulas, okay? Just remember that when they write it like this with the B factored out, C is the phase shift only, okay? This value C right here in what I taught you, right here, is not the phase shift. You have to divide it by what? By this value B first for it to be the phase shift. That's the difference. So basically, if that makes sense to you, if I were to write these equations, and this equation is A, okay, let's write this equation. So if I were to write this equation as 3 cosine of 2, this is the value B, 2 x, right? Is it an x, or they're using x, right? Yeah, x minus, and this is without it being factored, pi over 2. Sorry, I'm moving back and forth so I can see. And then plus, or is it minus? Yeah, it's a minus. Minus a 1? Yeah, minus 1. Here's the equation I would have written. The way I would have written it without factoring out a B. If you factored out a B and write it the way they would have written it, so they're factoring out this value 2, this would be this. That's their value for C. These equations are exactly the same. But what I'm telling you is if you factored out that 2, this is your phase shift. It's pi over 4. To find the phase shift from what I have, from this top equation, you have to divide this quantity C here, by this quantity B. If you were to do that, you would get pi over 2 divided by 2, which is again pi over 4. It's the same thing as that one. So keep that in mind. That's kind of the tricky stuff. So just remember that if they factored out the B already and wrote the equation like this, if that doesn't make any sense to you, just remember that this right here is the phase shift. So you don't have to do anything to it. Just find the phase shift from the graph. That's your value for C when they factored out the B, okay? Hopefully I didn't make that too confusing, but that's what's happening. Just remember these equations are exactly the same. Okay, they really are. Okay, that will be that question. Okay, so we're on number 2. Consider the triangle ABC, where AB is 10, BC is 7, and the angle CAB is 30. Find 2 possible values of the angle ACB. All right. So there's 2 ways we can draw this triangle, at least. So let's do that. If I make this side A and this side B, the distance between them, they're telling me is 10. And then I have a quantity BC, which is 7. So this could go out like to here if I wanted to. I could put it here. This could be where C is. And that side is 7. And then this right here would be your triangle. Okay. And they're telling you that angle CAB, which is this angle A, you can identify the angle when they write it like this. It's just the middle one with the caret on it. That's where the angle is. It's 30 right here at A. Okay? They're telling you this. So that's one possibility. And another possibility for this triangle is if I draw it this way. Say if I switch the A and the B. Let's call this point B. And I'll call this point A. And then B, this will be 10, this distance. And then from B to C, which is only 7, should be shorter. And then this right here. I have to be careful. That's not a right angle, okay? So the way I draw that, let me kind of redo that because that'll confuse people. They'll say, oh, it's a right angle. It's not really. Let's make that a little more deliberate here. Let's go a little further like this. That's 10. This is 7. Oh, it looks the same. Went out too far. Here we go. That's C. There we go. I don't know why it doesn't give me a straight line. There we go. That's 7. Okay, so this is another possibility. And here's the angle A right here, which is 30. The information is consistent but for both triangles, okay? But what you're noticing here, I hope you're noticing, is that the angle C right here is acute, and this angle C right here is obtuse. Even though the information I've used from the very top is consistent for both triangles. So those are two possible triangles here, okay? And what we're about to do is solve for the angle C. That's what they want me to find, and there's two possible values. One's acute and one's obtuse. And we have to use the law of sines to find this angle, okay? So this is referred to commonly as the ambiguous case of the law of sines. Ambiguous because it could be, what, two possible answers. Ambiguous. I really can't spell today or write with this pen. I do apologize. Ambiguous case of law of sines. Okay. And I put this in the review because this is an important thing to keep note of when you're dealing with the law of sines. Because there's two possible answers many times. All right, here's the deal. So if I solve this, the law of sines says that the sine of any angle over its opposite side is equal to the sine of any other angle over its opposite side. So I can write this as being the sine of C, which is this angle right here in red, over its opposite side, which is 10, side opposite that, right, is equal to the sine of 30 over its opposite side, which will be 7. So I could solve this for C by multiplying both sides of this equation, let's do in green, I guess, by 10. So C would equal 10 sine of 30 over 7. Of course, the sine of 30 degrees, if you know your unit circle, is a half. So this is 10 times a half, which is 5, over 7. That's the sine of C, not C, but sine of C still sine of C. So to find the value for C, we will just find the sine inverse of 5 over 7 to get rid of the sine. So the sine inverse of 5 over 7, and I'll put that in a calculator. And right here at the bottom here, let me clear this screen. I'm in radian mode, for this is the Desmos calculator, so I have to switch this little toggle here on the bottom to degree when I do this, okay? So just be careful if you're using the Desmos calculator. I'm only using this calculator. I usually would use an Inspire, but I'm assuming that some students don't have it, so I'm using this quite deliberately to show you can still do the whole test on the Desmos app, right? You can download it for just any device pretty much, whether it's Android or Apple. So even if you have a cell phone, you can use this calculator. So here's what I'm going to do. Function right here, I'm going to go to sine inverse. go back to main and type in 5 over 7. Sine inverse of 5 over 7. This angle is 45.58 degrees. So that's what this is. That's one of your answers. The other answer will be for this other triangle. But how do you find it? Okay, no matter what I do, if I keep typing in the law of sines actually into this calculator, it's always going to give me this angle. There's no way the calculator is going to tell me the other one by using the law of sines. So how do I figure it out? Well, this is where what they're testing is your understanding of sines. Okay, sines have two angles that give you the same sine ratio. So think about this. If I were to tell you there's an angle here called 45.58, you always use a reference angle to find trig ratios. So what a reference angle is the shortest distance from this x-axis here to the terminal side of the angle. In this case, it's just the angle itself. That is the reference angle. So you would use the ratio of this, which is your y, over r. Remember, my y and my r are 5 over 7 for this. So it's going to be 5 over 7. Okay, we said that right here. Now, that's true for that angle, but it's also true for another angle. It's also true for this angle over here, where this reference angle is 45.58. And the shortest distance from this x-axis to this terminal side is that reference angle. But that's not the angle itself, not that reference angle. The actual angle is all the way around. That's the angle you're looking at, even though you're using that reference angle. So this is basically testing your understanding of how to use reference angles. So this distance here is again 5, and this distance here is again 7. So the sine of this lime green, let's do blue. The sine of this blue angle is also 5 over 7, just like it is for this little angle here, which is 45.58. So what I'm telling you then is to find the sine of the bigger angle, which is the obtuse angle. Not to find the sine, but to figure out what that big angle is. You will take the angle you already know, which is 45.58, and subtract it from 180. So here's another possible angle. It's 180 minus 45.58. So if I subtract this in the calculator, it's going to be 134.42. So that's this one. 134.42 degrees will be this one here. Those are the two possibilities for the angle C. So what did you get out of that little discussion? This. You should get this out of it. I'm going to tell you that the sine of 45.58 is equal to the sine of 134.42. They both have the same sine ratio, and that's going to be for both 5 over 7. So if I do the sine inverse of 5 over 7, it's only going to give me this one, but there's still this one that's possible. And you find it by subtracting the first one you got from 180, if that makes sense to you. Okay, so that's that. Hints, meaning use the answer I just found. Find ABC, the angle B, basically they want the angle B, given that it is acute. So angle B is different. Angle B, I'm running out of colors. Just pick something else. This green will be fine. Angle B is this angle. Or this angle. I want the one that's acute, the one that's smaller than 90. So I'm going to use this one. This one is acute. And this one is obtuse. So I want the one where angle B is acute. They tell me that right here, where angle B is acute. So I'm going to use this triangle on the right side. I'm going to use just this one right here on the right side. Okay, so that means I'm going to use the value 134.42 for the angle C, which I just found. Okay, so let's use that. So to find this, what I'm going to do is to find this missing angle B is I'll add the angle C to the angle 30. All the angles inside the triangle add up to 180. So I'm going to add this angle plus this angle and subtract it from 180 to get the missing B. That's it. That's the whole question. It's kind of goofy. So let's do this. It's going to be 180 minus the sum of 134.42 plus 30, which is the same thing as 180 minus 164.42. And what is that quickly in the calculator? 180 minus 164.42. That'll be 15.58. If you don't round so much. Degrees. This is your angle B. Angle A, B, C if you want, which is just called angle B. It's the same thing for me. And that's it. That's your answer. Okay, so this is number 3. Consider the following circle with center 0 and radius 6.8 centimeters. Okay, the length of the arc PQR, so let's highlight that, from P to Q to R, this is the arc length, is 8.5 centimeters. And this is 6.8 centimeters, the radius. The question is, find the value of the central angle theta. All right then. So if you remember the definition of a radian is equal to this arc length, which I call L, divided by this radius. That's the definition of a radian. So this angle will be in radians, okay? But it's just L over R. This is always the case. So you can use this formula or rearrange it whenever you need something. If I wanted to find the arc length, I would say arc length L is equal to R times theta. It's the same equation, just rearranged, okay? So it really depends what you're looking for. This is what this is going to be 8.5 centimeters divided by 6.8 centimeters. The units for centimeters will cancel, and this will give you just the angle in radians, okay? So remember, when you're dealing with circles, the angles are in radians. And if they're not in radians, when they give you the problem, you must convert them to radians, because this relationship is literally the definition of a radian, okay? So this is 8.5 divided by 6.8. This is going to be 1.25 centimeters when you divide that. Okay, so that'll be your answer for that question. It's very easy, and I'll illustrate that in the calculator here. This is going to be 8.5 divided by 6.8, and that is 1.25, as you see. Okay, there you go. All right, find the area of the shaded region. So they want the area of this part that's shaded. So there's two ways you can attack this question. There's usually more than one way to do something. So if I'll have two methods here. I'll have method 1. And I'll have method 2. So I'll show you both ways. Usually there's more than one way to do something. So here's the deal. The first method is if I want the area of the shaded part, I can find the area of the circle and subtract the area of this slice of the pie here called a sector. Okay, so what I want is the area of the whole circle, and I want the area of the entire small sector there. And then I can say the area of the shaded part is equal to the area of the circle minus the area of the sector. Okay, so what's the area of a circle? It's pi r squared. The radius of the circle, they tell you in the question, is 6.8. So this is pi times 6.8 squared. What's the area of a sector? The formula you should know is 1/2 r squared theta. So this is 1/2 6.8 squared times times the angle theta, which is my central angle I found in the previous question, 1.25. Okay, so this is really, when I say area of the sector, I'm talking about the area of the slice of the pie. That's my sector right there. Okay, so there's no ambiguity there. So what's this answer? Let's change this up. This will be, let's put that in a calculator. This will be pi times 6.8 squared. That'll be 145.27. That'll be in square centimeters, if you care about that. And this part, we'll find, this will be 1/2 times r squared, which is again 6.8 squared, theta, which is 1.25. So this will be 28.9. And now that I have this and this, I'm going to subtract them. So this is 145.27 minus 28.9. This will be 116.37. This will be in square centimeters. If you leave your answer like that, you'll get full points, even with the examiner. So you can leave the exact answer. I obviously rounded for the area of the circle there, but if you were to not round at all on the test, they won't take off any points historically. So maybe in chemistry they would for rounding, but they don't really care about that. If you do round the final answer, round to 3 significant figures. So this answer would be 116 to 3 significant figures. But they'd give you credit for that, but I wouldn't round it at all, honestly. If I'm taking this test, I would just leave it like this. And I'll get all my points, okay? So they're not really particular about it for IB-Math-SL. Okay, method 2. Instead of finding the area of the circle and subtracting the area of the small slice, I could just actually treat the area of the shaded region as its own sector. Because it is. It's a sector. It's just a larger of the two. So we have a shaded sector and a non-shaded sector in the circle. So how do you find the area of the shaded sector just by itself? Well, there's an angle here. Right there. Okay. We already know that this angle here is 1.25. We found that in part A. But the other angle would be 2 pi minus the angle we already know, which is 1.25. Since the entire circle has an area of 2 pi, we'll subtract this area of the central angle for the slice of the pie here, and that's the angle left over for the shaded region, is 2 pi minus 1.25. So now we can just treat it like its own sector and go straight for the answer. So the area of this shaded region directly is the area of a sector formula, 1/2 r squared theta. So this is 1/2 times 6.8 squared times this angle theta now is 2 pi minus 1.25. And then I put that directly into the calculator and see what happens. So we have 1/2 again times r squared, which is 6.8 squared, times the angle now of the shaded region, which is 2 pi minus 1.25. And of course, that answer is 116.37 again. Same answer as the other method. So there's more than one way to do things, of course, and that's it, okay? So that's this question. We're going to move on to number 4, which is probably the hardest question on this review. Okay, this is number 4. The following diagram represents a large Ferris wheel at an amusement park. The points P, Q, and R represent different positions of a seat on the wheel. As you can see, this is kind of a long question. This is a paper 2 question. You would get about 15 minutes on average to do a question like this. Okay, so we're just going to kind of pick this apart and figure out what they're telling us. Okay, so it says the wheel starts, so it says the wheel has a radius of 50 meters and rotates clockwise at a rate of 1 revolution every 30 minutes. Okay, and the seed starts with the lowest point at P, which is right here. And that height for P is 1 meter above the ground to start with. So when you get onto the Ferris wheel, you're already 1 meter above the ground already. Find the height of the seat above the ground after 15 minutes. Well, it does a full rotation every 30 minutes, so 15 minutes is half of that. So if you do half a rotation, you would only go halfway around, and you'd be at the top. Okay, so how high are you off the ground? Well, they tell you the radius is 50. So this is also 50. So this total height that you are off the ground is 1 plus 50 plus 50, which is 101 meters. Which is really easy. No work really to show for that. All right. After 6 minutes, the seed is at point Q. Find the height above the ground at Q. Now, that's kind of a tricky question because it requires quite a bit of knowledge here, but here's the deal. This is the middle of the graph. This is a circle that's rotating, so it's going to create a sine wave or a cosine wave. Technically, you could represent any sine wave as a cosine wave or vice versa, but it's going to create a wave. So that's the bottom, the middle, and the top of your wave. Since you're starting from the bottom, this will go upward to some point here. And actually, we can probably make that more steep. Or something more along the crescent here. And let's do something like this. To the top. Here. Back to the bottom and so forth. Creates a wave. And this will keep going forever. Technically, if the Ferris wheel kept going forever, if it kept rotating forever, this is what would happen. All right. So they want to know the height after 6 minutes. Well, it takes 15 minutes to get to the very top. 6 minutes, right, is going to be quite a bit less than that. Less than a third of that anyway. So that'll bring me, let's change this color to something I can see. Maybe green. All right, so it'll be like maybe right here or something. I don't really know. That's how far it rotates after 6 minutes. So how far off the ground is that? That's the question. So you really need some sort of equation to model the height of this Ferris wheel with respect to time. So I need height of the Ferris wheel with respect to time, okay? And technically in this question, even though I didn't include it on here, they would have given you the equation. So when I actually copied this equation over to this paper from the test that I ripped it off of, I didn't actually copy the part where they had the equation on it. So it says there's an equation that models this Ferris wheel so it models the height of the Ferris wheel with respect to time. So here's the equation that you should have as part of this question for C and D specifically. So right after B, they give you this equation, and here's what it was. It was 50 sine of B factored out x minus C plus 51. Okay, so that should have been in the question. I just didn't copy it from the test. And technically, I didn't teach you to write a sine wave this way. You can write it as a sine wave, and that's what they're going to do. But they give you that equation, and that's for part C, really, for part C and D. So technically, you really don't need that equation to do any of this question, to be perfectly honest, if you can just figure out what's going on. So let me show you what I'm talking about. All right, they don't have to give you that for you to figure this out. Here's the deal. They tell you enough information right here. So I taught you how to model an equation this way for a sine wave. I said f of x is equal to a sine of bx minus c plus d. Okay? And a is the amplitude. That's the distance from the top of your wave to the middle. And I already know that distance is going to be 50. That's the distance from the top of the wave to the middle. So that would be 50. So this is already common sense. And then sine, let's find d. D is the vertical shift. Technically, the sine wave should be centered, the center of the wave should be on the x-axis here, right? At 0. But now the center of the wave is right here. So what's the distance I had to shift up from 0 to get up here, where the middle of the wave is, okay? that is going to be what? 51. That's going to be 50 plus 1. So this will be 51. And that's pretty common sense. Like, you really don't need to be told these things, okay? Because they're all right there in front of you. Now, the period. Remember that this is going to be a height. This y-axis here is a height. And this x-axis here, oops. This x-axis here is time. So when you measure the period, you're always looking at the variable, the x-axis here, right? And that's time. So the period is just a period of time that you go one revolution on the Ferris wheel. That's what the period's going to be, right? Because after a revolution, the whole pattern starts over again. And you can measure the period different ways on the actual waveform. You can measure it as the distance from the bottom to the bottom, for instance. Okay, if you want to. So that's one way of doing it, right? Or the top to the top, or so forth, right? That's going to be one revolution, and then after what? After that, after you go from the bottom to the bottom, the whole pattern repeats itself all over again. That's what periodic functions do. They periodically repeat themselves. So basically, in this question, my period is 30 minutes because they tell me right here that that's how long it takes to do one revolution. So that's the length of the period. So here's what I'll tell you. The period is always 2 pi over b if I write the equation like this. And they tell me that happens to be 30 minutes. So we'll solve this equation for b. b will equal 2 pi over 30, which is pi over 15. So this will be pi over 15. Right? We can call that t instead of x. And this will be h instead of f of x, right? That's the height with respect to time. Now, the last thing I need to figure out is the value c. And that's found from the phase shift. Okay, so the phase shift is basically how far we shifted from where the graph should usually start to where it's actually starting in the reality of the question. So technically it's a sine wave. Sine wave should start at the middle, right there where that pivot point is, right? And it should start in the middle, and it's actually starting on the bottom. So if I go this rotation through here, that's where the middle is. The middle should be here when it starts the wave, and it's actually moving to where the middle is right there. So this is your phase shift, this distance. Okay, this distance, let's do this in a different color, that I have traveled here. That's the phase shift. And the question is really what is the phase shift, okay? But if you think if I did one revolution, this can be broken down into quarters. All right, let's do this in quarters here. So if I say 1/4 of the revolution is this. This will be the second quarter. And then the third quarter. And then the fourth quarter. So it's 1/4 of the revolution is what I'm telling you, okay? Is that distance there for the phase shift. And that really easy to find now, because if I know one revolution takes me 30 minutes, the phase shift, remember, is the same thing. It's the same variable as time. So it's going to be basically what is 1/4 of 30 minutes. So we'll just divide 30 by 4. So 30 divided by 4 is 7.5, or you can write that as really 15 over 2. And that's really my phase shift. Now, if you write an equation like this in the form that I taught you, the phase shift is found by c over b, those two quantities. And as it turns out, this is going to equal 15 over 2. That's what the phase shift is, literally what it is. So technically, if I'm writing an equation with this value c, I would have to solve it for c, okay? But I already know the value b because I found it already. It's pi over 15. So what I'm telling you is that c over pi over 15 is equal to 15 over 2. And I really should write that somewhere else so you can see it, because I always run out of space here. Technically, you would have an answer document to write this whole answer question, the whole answer for this question somewhere. And I am not writing on an answer document, I'm actually writing on the question itself, which is why I'm quickly running out of space. But this is going to be c over 15 over pi, which is equal to 15 over 2. So what I'm going to do is multiply both sides by pi over 15. say 15 over pi, it's actually pi over 15. So I'm going to multiply both sides by pi over 15, like this. And these would cancel. And these 15s would cancel. So my value C would be pi over 2. That's what's left, pi over 2. So I would have a pi over 2 here. And this could be my equation. And I literally just created an equation from nowhere that would model the height of this Ferris wheel. Okay? And that's literally what I've done from nothing. All right? And now, once I piece all this, you take all those pieces and put it together. Remember, if you don't understand how sine waves work, you can't possibly make this equation. So you have to have a very good understanding. Now, after 6 minutes, what's the height of the seat at point Q? We're at Q, actually, so they tell me it's at Q. What's the height of the seat right here after 6 minutes? Okay? And I want you to find that. So what are we going to do? We're just going to plug in 6 minutes into the time for the equation I found. And then it's going to give me a height. It's literally plug into the equation. So my height is equal to 50 sine of what? Pi over 15. The time I'm going to plug in there is 6 minutes. That's my time. Minus pi over 2 plus 51. This is the equation I created, mind you. Okay? And this would work perfectly fine. And then you could just put that into a calculator. All right, so here's where we go. We could say 50 times sine of what? Of pi over 15. And then what? We would have times 6, that's your time, minus, let's make another fraction, pi over 2 is what I called it. And then plus 51. So this answer doesn't look reasonable because I'm in degree mode. So be careful there. If I switch it to radian mode, it gives me the correct answer. All right, so the radian mode, the correct answer is 35.51. Okay, and this will be in meters. So here's what I'll tell you. If they don't tell you if it's in degrees or radians, assume it's in radians, okay? Because they don't tell you here, right? But I want you to assume it's in radians unless they say somewhere or show you somewhere, give you some indication it's in degrees. All right, just food for thought. Now, find the values of B and C, and this is the equation they would have given you in the question for this question, okay? They want you to find this value for B and this value for C because this equation would have appeared right before this question somewhere. I just didn't include it in the review because I didn't copy it, the whole entire question from the test like I should have. So I left out one sentence and it had the equation in it, and this is what it was. Now, this equation that I have here is not the same as the equation that I have. Well, it is the same equation, but it's written differently, okay? So in this case, my B is the same. That's my value for B. It's the same thing as this value for B. So B is easy to find. I already found it. It's pi over 15. But this value C here is not the same thing as pi over 2 because this equation that I have here is written like this, is written as bx minus c plus d. And what's the difference between this equation and the one that I have right here is they factored b out of the parentheses. Well, they factored it out of x minus c. So my c values are actually different, okay? And what I'm going to tell you is whenever you without you thinking too much about what just happened here, what I'm going to tell you is if you see the function with this b factored out, this right here is your phase shift. It's not c over b anymore, it's just c by itself. Okay? To find the phase shift this way, I have to divide this c by this b here, but I'm not doing that. This is just the phase shift by itself if you factor it out already. Just know that, okay? And then you won't get confused. So, if my phase shift is c, I just have to say c is the phase shift. I already found it though. The phase shift is what? The phase shift I found to be 1/4 of the period, which was 15 over 2, or what? Or 7.5. Either answer would be fine, but I told you that already. That's the phase shift. So your answer for C here is just the phase shift. And that's what it always is if it's written with the B factored out of this, okay? It's just whatever the phase shift was. So in this case, you can call it 15 over 2, or you can call it 7.5. And that's all the explanation I'll give you because, honestly, I don't want to confuse you by explaining more. It seems like the more I explain things, the more confusing it gets. So I'll leave it at that. All right, last question. Hence, find the value of T the first time that the seat reaches 96 meters above the ground. Now, technically, they give you an equation for height, so you already have this equation. This equation is 50 sine of, if I plug in the b, it's pi over 15. And then this will be times x minus 15 over 2. This is technically your equation that you're playing with. If you plugged in the b and the c that we found. And the height, they tell you, is 96, so they actually give you that value. So all you're really doing is solving this for x, or you're solving this equation for x, or t actually, right? This would have been a t. I don't know why I say write this function, is a function of x when it's actually a t, I should say. I should write this as a t, it's not an x, let's be careful. So I'll call that a t. So how do we solve that? We could insolve it in a calculator if you had one, or if you don't have a calculator, a graphics calculator like an Inspire, I can use Desmos. So what I'll do is I'll just graph the left side and I'll graph the right side separately and figure out where they intersect. So let's see what happens. And here we go. So the first thing I'll graph is the right side, and I'll say, okay, that's 50 times sine, and then a fraction, and this will be pi over 15. And then I'm going to subtract. And don't forget there's an x there. We'll call it an x for this. So remember that calculators don't know t's and p's and stuff and h's. They have to use x and y always. So you just parallel them. And it should be no big deal if you understand what's happening. This will be 15 over 2. And it keeps drawing as I add stuff to it, and it's going to be plus 51. So that's your sine wave. If it doesn't look like a sine wave, I'll zoom out. There it is. Now, you're thinking, well, this is not the correct equation because this should be centered at the y-axis, right? And there, you'd be correct because I need to factor this b out. So I didn't factor it out correctly when I wrote this equation. And I'll have to add a parentheses there to make sure it's factored. Now it's fixed. So now I have a wave that looks more appropriate. So once I have this drawn, this is what your wave looks like, okay? Really, it's starting right there on the y-axis. This is your Ferris wheel. So it's going to start there on the y-axis at 0, and then it's going to go to the right. It's going to do that. So let's graph 96, the other one, the left side of the equation. Say y equals 96. You have to type it in like that for Desmos. And there